2.1, transformations of quadratic functions. Like I said, we're going by units, not chapters. So this chapter 2, section 1 is part of the same unit as the past few sections we've been doing. We're talking about transformations of quadratic functions, and they're pretty similar to what we talked about yesterday. Okay? So we've talked about quadratic functions a little bit before, but this is what a quadratic function is. Let me turn this other light off for you. Make sure you don't fall asleep on me. A quadratic function is a function that can be written in the form f of x equals a times x minus h squared plus k. You need to have that form written down. F of x equals a times x minus h squared plus k, where a does not equal 0. The U-shaped graph of a quadratic function, we've already talked about this before, is called a parabola. You guys remember me calling them parabolas? Yeah. For quadratics? So in section 1.2, we graphed quadratic functions using tables of values, correct?
Yeah.
Okay. You can also graph quadratic functions by applying transformations to the graph of the parent function, f of x equals x squared. Yes?
Does that say x minus h squared?
Yep. F of x equals a times x minus h squared plus k.
Oh, thank you.
What is it called?
A quadratic function is a function that can be written in that form. Do what?
Isn't it like I forget what they're called when the number goes under instead of up, goes down.
Denominator.
No.
Can I go to the Charles class?
Like instead of an exponent,
Yeah,
it's called a subscript.
subscript. There you
Can I go to the Charles class? I have my water in there.
Not right now.
I need my water though.
Okay, are there any questions about quadratic functions and their graphs and stuff like that? About this slide?
Dude, it was a small one.
Shh. Can I move on? Okay, so we can have horizontal and vertical translations of our quadratic functions just like we did our linear and absolute value functions. Okay? The formula is still the same from yesterday. For horizontal translations, it is still f of x minus h. Okay? So if we're translating the parent function horizontally, it'd be f of x minus h, which is x minus h squared, because you plug x minus h in for x into your parent function. Okay? So, for horizontal translations, listen up, quit talking. For horizontal translations, if my h value is less than 0, what numbers are less than 0?
go. Negatives.
Negative numbers.
Yep.
So if my h value is less than 0, it shifts left.
Left.
When my h value is greater than 0, what numbers are greater than 0?
Positive numbers.
Positive numbers, it shifts right. But our formula is x minus h. So if I plug a negative number in there, what's x minus a negative? It'd be x plus that number, right? So that's why we do the opposite of when it's inside the parentheses. If that's a plus sign, we shift left. If that's a minus sign, then we shift right. Does that make sense?
So you would change your signs?
Yeah. Because when I plug in a negative number, that turns into x plus that number.
Okay.
When I plug in a positive number, it just stays as x minus that number. Write that down, yeah. This is also in your textbook. Vertical translations. Our formula is still f of x plus k, just like it was yesterday. You guys remember that formula from yesterday? Yeah. So, for our quadratics, for the parent function, that would be x squared plus k. Our function plus k. So when my k value is less than 0, when it's negative, it shifts down. And then when my k value is positive, it shifts up. So when it's outside the grouping symbols, we follow what the sign says. If it's positive, we go up. Negative, we go down. Does that make sense? So, like I said, the formulas are still staying the same from yesterday. We're just talking about quadratics instead of linear functions and absolute value functions. You okay with that? Still the same formulas. F of x minus h for horizontal translations. For vertical translations, f of x plus k. Questions on our translations? Can I move on? Okay, example 1. Describe the transformation of f of x equals x squared represented by g of x equals x plus 4 squared minus 1, then graph each function. So it first wants me to describe the transformation and then graph each function. So, can anyone describe the transformations that are occurring here to me?
Looks like a left translation.
If it's going left, what kind of translation is it?
Horizontal.
Horizontal translation. How many units is it going left? 4.
Yep.
Does everyone see that? We have plus 4 inside the parentheses. Remember, if it's inside the parentheses,
It's opposite. I can get my water now.
Is it in?
parentheses, quit talking.
I've got
When I'm adding or subtracting something in the parentheses, it's a horizontal translation. And we do the opposite of what the sign says, right? So here I've got a plus 4 inside the parentheses. So I know it's going to be a horizontal translation. And since it's plus 4, I know I'm going left. So I'm doing the opposite of what that sign tells me to do. Going left, how many units? 4. Do I have any other transformations occurring?
Plus 1.
Huh?
Wait.
What about minus 1? So very good. It's which kind of translation? Vertical translation. Remember, when I'm adding or subtracting something outside of grouping symbols, it's a vertical translation, and we follow what the sign says. We got a minus 1 here, so I know I'm going down 1. So I've got 2 transformations occurring here. A horizontal translation going 4 units to the left, and a vertical translation going 1 unit down. So I would say G is a horizontal translation. 4 units to the left, followed by a vertical translation one unit down. Does that make sense? We can get all that information just from our function. Does everyone see how it's a horizontal translation 4 units to the left, vertical translation 1 unit down? Everyone okay with that?
Yeah.
Okay. Can I erase and draw my table of values for my graphs? Let's graph our parent function first. What is my parent function?
F of x equals x squared.
F of x equals x squared. So what values do you want to use for my parent function to plug in for x?
1.
1, 2, 0,
Negative
-1, -2. Let's use those 5 values. If I plug -2 in, what's -2 squared?
4.
4. -1 squared.
1.
0 squared.
0.
1 squared. 2 squared. Everyone okay with that? We've done that multiple times in the past. That's why I went so fast with it. You okay with that? So -2, 4. Be right there. -1, 1. 0, 0. 1, 1. And 2, 4. And then what's the shape of a parabola? It's a U shape, so I know I need to connect it using a U shape. It's a U. We all know it's a U.
Okay.
Questions on my parent graph here? Now, I need to graph my g of x function. X plus 4 squared minus 1. There's two ways I could do this. I could create another table of values. Or, I can just look at the transformations that are occurring. If it's just a translation, it's pretty easy just to graph the translation without doing a table of values. Each point, I'm going to translate 4 units to the left and 1 unit down. Does that make sense? So here I'm going 4 to the left, 1 unit down, and putting that point. 1, 2, 3, 4, 1. Everyone see what I'm doing? Take this point, go to the left 4 and down 1. 1, 2, 3, 4, down 1. This point, take 4 left, down 1. Same thing with these 2 points. 1, 2, 3, 4, down 1. 1, 2, 3, 4, down 1. And then what kind of shape is it again? U shape, it's a parabola. And there's my graph of g of x. Any questions on how I got that? Once again, I could have created another table of values for g of x if you wanted to. Okay? When we get to stretches and shrinks, it is going to be easier to create a table of values rather than try to graph the transformations, because it's going to be hard to gauge the stretch and the shrink. But translations, do translations affect the size, shape, or orientation of the graph? No, it just moves it horizontally and vertically. Okay? Can I move on? We good with example 1?
Yeah.
Okay. Reflections. Still the same formulas that we used yesterday. Reflection in the x-axis is still negative f of x. So for our quadratic, the parent function, if I take the negative of my function, that just becomes negative x squared. It just flips over my x-axis. My x-axis is my axis of symmetry. Okay? Does everyone see that? Still the same function from yesterday. Reflection in the y-axis is still f of negative x. So if I plug negative x in for x, negative x squared just turns into x squared again. So it's essentially the same graph. If I reflect my parent function of my quadratic over the y-axis, it's the same graph. Does that make sense? Y equals x squared is its own reflection in the y-axis. Any questions about reflections? The formulas have not changed, have they? Anytime we're doing transformations, the formulas will not change. Just the types of graphs that we're doing will change. Can I move on? Yes, no, maybe so?
Yeah.
Yes. Now let's talk about stretches and shrinks of quadratic functions. Horizontal stretches and shrinks is still f of ax. For horizontal stretches and shrinks, do you remember what our factor is? Is it 1 over a or just a? 1 over a. Very good. So for our quadratic function, I'm plugging ax in for x. So I get ax squared. So when my factor is between 0 and 1, that's going to be a horizontal stretch, which is being stretched away from the y-axis. So it's getting wider. Whenever my a value is greater than 1, I'm shrinking it towards the y-axis. It's a horizontal shrink towards the y-axis, so it's getting skinnier. Vertical stretches and shrinks is still a times f of x. So for our quadratic, it'd be a times x squared. For our vertical stretches and shrinks, is it by a factor of 1 over A or just A? Just A. So my vertical stretch, when A is greater than 1, it's a vertical stretch. So it's getting pulled away from the x-axis. It's stretching it upward, making it skinny. Whenever A is between 0 and 1, it's a vertical shrink. It's stretching or shrinking towards the x-axis. Okay? Any questions about any of that? Still our same formulas. Okay, can I move on? Example 2, describe the transformation of f of x equals x squared represented by g. Then graph each function. Same directions as we had earlier. We're just dealing with stretches and shrinks and some reflections as well. So, letter A, g of x equals negative 1/2 x squared. G of x equals negative 1/2 x squared. Can anyone raise your hand and tell me what kind of transformations are occurring here? Anyone raise your hand and give me one of my transformations occurring here? Huh? Horizontal stretch? Is it a horizontal stretch?
Vertical shrink because it says it's below.
Am I multiplying by something inside parentheses on letter A? Multiplying by something outside the parentheses. So it's not horizontal. Horizontal would be inside the parentheses. It's a vertical stretch. So I'm multiplying by something outside of grouping symbols. Does that make sense? Is it a vertical stretch or a vertical shrink?
Shrink
Vertical shrink. Why is it a vertical shrink?
because it's less than 1 but greater than 0.
Very good. It's between 0 and 1. It's a vertical shrink.
Don't you lie to yourself out there.
So, this is letter A. G is a vertical shrink. What's the factor here? What? 1/2. Very good. G is a vertical shrink by a factor of 1/2. Are there any other transformations occurring here? Huh? Very good. Why is it a reflection over the x-axis? Not x squared. The negative outside the grouping symbols, right? So if I have a negative outside the grouping symbols, I know it's a reflection over the x-axis. So G is a vertical shrink by a factor of 1/2 and a reflection over the x-axis. Does that make sense? Questions on how we're describing our transformations based on the function. Can I erase to create my table of values for my graphs? So let's do our parent function first. I'm going to create this real quick because we've already done it multiple times. So our parent function would be negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Here's my parent function. Everyone okay with the parent function of a quadratic? Okay, like I said earlier, it's going to be easier to create a table of values since we have a vertical shrink occurring here. I can't really graph based from my parent function a vertical shrink or stretch. Okay? It's going to be easier to just create a table of values. So what are some values you want to plug in for x here? Keeping in mind we have a negative out or a fraction out front. So we're probably going to want to do multiples of 2. So negative 4 might be a good one. Let's try negative 4, see what happens. What's negative 4 squared?
8.
Negative 4 squared? 16. And then 16 times negative 1/2.
8.
Positive or negative? Negative 8. Okay, let's try negative 2 now.
What are you trying to do this by?
I'm plugging in to my g of x function. So I plugged in like that. So negative 4 squared is 16. 16 times negative 1/2 is negative 8. Does that make sense?
Did you do the same for the first one or no?
I did for the first set. That's just my parent function, f of x equals x squared. That's what we did right here. We already did that on this slide, so I already created just a table of values real quick. Okay? So let's plug in negative 2. What's negative 2 squared?
4.
4. 4 times negative 1/2. Negative 2. When I plug in 0, what do I get? 0, 0. Plug in 2 and 4. 2 squared. 4 times negative 1/2. I'm going to get negative 8 again. So negative 4, negative 8. It'd be here. Negative 2, negative 2. It'd be here. 0, 0 is already graphed. 2, negative 2. And then 4, negative 8. Connect my points with a parabola. And there's my graph of g of x. What kind of a shrink or stretch did we say it was? Vertical what? Shrink. So does everyone see how my graph kind of shrunk vertically? Meaning it kind of got a little wider. Does everyone see that? And then it was flipped over my x-axis. Okay? So there's my graph of letter A. Questions on letter A?
No.
No? Can I erase and move to B?
Sure.
Letter B. G of x equals 2x squared plus 1. Raise your hand if you can tell me a transformation that's occurring here. Yes?
Oh, shrink.
What kind of shrink? Horizontal shrink. I'm multiplying by something inside the grouping symbols. That number is greater than 1, correct? So it's a horizontal shrink. So G is a horizontal shrink. By a factor of what?
2.
Not 2. Remember, when it's a horizontal stretch or shrink, it's by a factor of 1 over A. So what's my A value here? 2. So 1 over A would be 1/2. By a factor of 1/2. Can someone name another transformation that's occurring here?
There's another?
There's plus 1. What do we call that? Huh? Vertical translation. So G is a horizontal shrink by a factor of 1/2 and a vertical translation up 1 unit. Does everyone see that? Is that all the transformations that are occurring?
Yep.
Yes, they are. Questions on my explanation or my description on letter B? Can I erase to give me room to graph? No? Okay, I'm waiting. While y'all are writing that, I'm going to go ahead and graph my parent function. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. That's my parent function. Can I erase now? Okay. Everyone okay with how I graph my parent function? It's the same thing we've done on the past 2 slides. Now let's create our table of values for our g of x function. Okay, what values do we want to plug in here? Think about it. We're going to be multiplying by 2 and then squaring it and then adding. So it's going to get pretty big pretty fast.
2?
Let's try 2. What's 2 times 2?
4.
4. 4 squared? 16. 16 plus 1? 17. Wow. 2 comma 17.
So it's not true.
I can do that. My graph's just not big enough to do that right now. So let's pick another value to plug in. 1. 2 times 1? 2. 2 squared? 4. 4 plus 1? 5. We can do that.
So do we erase the first one or just keep it?
I'm just going to leave it there. It's still a point on my parabola.
Oh, so we're going to put on a graph?
My graph's too small for me to put it on there, but it's still a part of the parabola. It does make sense.
That graph is
1,
we need a
comma,
bigger graph.
5.
So what I'm asking is, are you going, I know your graph is small.
Right.
So can we just take the 217 off?
Sure. Yeah.
Okay.
What's another value you want to plug in?
Right, negative.
Negative 1? What's 2 times negative 1?
Negative 2.
Negative 2. What's negative 2 squared? 4. 4 plus 1? 5. So negative 1 comma 5. Yeah, 0 might be a pretty good one to plug in. What's 0 times 2? 0. What's 0 squared? 0. What's 0 plus 1? 1. Oh, we just thought it was 0.
0.
Remember, it's a vertical translation up 1 unit.
Zeros.
Does everyone see that?
Yeah. It's like a smiley face.
Okay, any number I plug in after that's going to get off my graph. If I plug in negative 2, I'm going to get 17 again. Okay? So let's draw a parabola based on these 3 points. So there's my parabola. Okay? We said it was a horizontal shrink, correct? So it got shrunk. We shrunk it horizontally towards my y-axis. So it got skinnier, right? And then it was a vertical translation up 1 unit. Everyone see that? Questions, comments, concerns about example 2? Can I move on from example 2? All right.
Oh my god.
Writing transformations of quadratic functions. The lowest point on a parabola that opens up. So if my parabola opens up, the lowest point on that would be right here. For a parabola that opens up, that would be my lowest point, right? Okay. Or the highest point on a parabola that opens down would be right there. That is called my vertex. The highest or lowest point on a parabola, depending on which way it opens, is called my vertex. The vertex form of a quadratic function is f of x equals a times x minus h squared plus k. You should have that already written down from the first slide, right? That is what we call vertex form of a quadratic function.
Wait, what?
That's vertex form of a quadratic function. Okay? I would make sure I knew that. That's vertex form. Where a does not equal 0, and the vertex is the ordered pair h, comma k. So the h is my x value, k is my y value. That's vertex form of a quadratic function. H, comma k is my vertex. So I might write my vertex form out like this, and I would label these parts. A indicates a reflection in the x-axis and or a vertical stretch or shrink. So if that's just some number that's a positive number, it's just going to be a vertical stretch or shrink. If it's a negative number, it's going to be a reflection over the x-axis and a vertical stretch or shrink. If it's just -1, it'll just be a reflection over the x-axis. Okay? H indicates a horizontal translation. K indicates a vertical translation. You may want to label each of those parts in vertex form. Are there any questions about vertex form of our quadratic functions? We good? Can I move on? Example 3. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis followed by a translation 3 units down of the graph of f of x equals x squared. Write a rule for G and identify the vertex. So we're trying to write the function to get from our parent graph, and we want to put it through all these transformations that are occurring. Okay? So let the graph of G be a vertical stretch by a factor of 2. So we're going to take it transformation by transformation. Okay? So my first transformation is a vertical stretch by a factor of 2. What's the equation or the formula for a vertical stretch? A vertical stretch. What's the formula?
A times f of x.
Very good.
Ax squared.
So I'm going to call this function after I do this vertical stretch, I'm going to call it L of x, because I want my last one to be G of x. Okay? So L of x equals A times f of x, correct? What's my factor here? What am I stretching it vertically by a factor of? What's my A value here? By a factor of
2.
2. So that's just 2 times f of x, correct? Does everyone see that? So L of x equals, what's f of x? What's f of x? X squared. So this just becomes 2x squared, right? So I'm multiplying 2 times my function. There's my first transformation. My function after my first transformation. Does that make sense? Okay, what's my second transformation here? A reflection over the x-axis. What's the formula for a reflection over the x-axis? Is it negative f of x or f of negative x? Negative f of x, right? So I'm multiplying my function by -1 essentially. So let's call this new function t of x equals negative L of x, since we're dealing with our L of x. Okay? Does everyone see that? So t of x equals negative, what's my L of x function?
X squared.
Not x squared, what's L of x? 2x squared I'm just multiplying my function by -1. That's it. There's my t of x. So this is my function after my first two transformations. Does everyone see that? So far we've got a vertical stretch by a factor of 2 and a reflection in the x-axis. How many more transformations do we have left? Huh? One more. Followed by a translation 3 units down. Now that I'm on my final one, I can now call it G because I want my final one to be G. So what's the formula for a translation that would be 3 units down? First off, what type of translation is that? Vertical or horizontal?
Vertical.
Vertical. What's the formula for a vertical translation? F of x plus k. So in this case, it'll be t of x plus k because I'm using the most recent function that I got. Okay? What's my k value here?
3.
Am I going up 3 or down 3? Huh? Minus 3. Very good. So this will be t of x minus 3. What is t of x? Negative 2x squared. I'm just subtracting 3 from my function. This would be my answer. Does everyone see that? You just take it transformation by transformation. So if you got 3 transformations, you got to do 3 different things. Okay? Any questions about that? So, g of x would equal negative 2x squared minus 3. It says write a rule for g, so I wrote a rule for g. This is my rule. And identify the vertex. Any ideas how I'm going to identify the vertex here? What is vertex form of a quadratic function? It's on the board. So this is technically in this form. What do you think my minus h is here? Do I have anything being subtracted from x?
No.
So what would it be if there's nothing being subtracted from it? 0. So if I wrote this in vertex form, that'd be negative 2 times x minus 0 squared minus 3. Right? Did that change this at all? No. Because if I take 0 away from x, it's still x. X squared would still be x squared. Times 2 would be negative 2x squared. Right? So did I change it at all? It just looks a little different. So what would my vertex be here? 0. Nope.
Wait.
Remember my vertex is h comma k.
Oh, so it'd be 0, what's that number?
What? 0, negative 3 would be my vertex. Any questions about that? Does that make sense? No, it does not. Okay.
I got it.
Any questions about example 3?
We got 2 minutes left.
Okay.
I get it, but I
Oh, my water.
Listen. Shh. Quit talking. Listen. We're not going to do this last example, but you would essentially do the same thing. You would take it transformation by transformation. So I would do the translation 3 units right first, and then I do the translation 2 units up next, and then I would do the reflection in the y-axis last. So you just take it transformation by transformation, use those formulas. Okay? Okay, don't hate me. I'm going to give you an assignment, but it's not going to be due till Wednesday. I'm not making it due beginning of next week. It'll be due Wednesday. Here it is. This is our last assignment of the semester. Okay? Pages 66 through 67, numbers 2 through 34 evens. Due Wednesday. That'd be December 15th on Canvas. Okay? I want you to get a little bit of practice with these, because some of these will probably be on the semester final. So you need to get a little bit of practice with them. This is our last assignment of the semester. Are there any questions about my recording before I end the recording?